In here I've got a well-established sensor for measuring solar radiation. This is called the SPN1 from Delta T. What the sensor does is it measures both the direct and the diffuse parts of solar radiation. So that's what comes directly from the sun and what comes from the rest of the sky. Using this very precisely shaped shading pattern and an array of detectors. And it's very neat because it doesn't need aligning to the North Pole, which means that unlike most other ways of doing this measurement, it can be used on platforms that move around. So this sensor is being used all around the world at the moment on all 7 continents and quite a few of the oceans. Its main uses at the moment are in solar power, for testing out sites for solar power stations and testing their performance afterwards. It's also used by a lot of meteorological organisations around the world and researchers into atmospheric science, climate science, crop growth. So the measurement that this sensor takes is the total amount of solar radiation across all the wavelengths, and that's very useful if you're wanting to look at the energy balance of a system or the total amount of radiation you're seeing. It would be more useful if we could get a spectral measurement of the different components of solar radiation. And what I've been doing in this particular project is using this optical system and putting spectrometers behind it. And here you can see the top is very much the same, and then there's spectrometers in this box here. So I do most of my development work in the beautiful Derbyshire Peak District, which is a long way from the sea, but a little bit closer to the sun than we are here in Plymouth. The reason for today's particular installation is to install this prototype spectrometer on the Brittany Ferries flagship, the Armorique, alongside some equipment that's been developed by Plymouth Marine Laboratory. That will then be sailing backwards and forwards across the English Channel over the next several months, and my instrument will be measuring the light that comes down from the sky, and the Plymouth equipment will be measuring the light that is reflected back off the ocean surface. And by combining those two, the aim is to get a better measure of what's in the water. Well, here we are. We're on the top deck of the Armorique, and we've just spent a happy morning installing all this equipment. The spectrometer is now strapped to the railings and will be continuously measuring the solar radiation coming down. In the background you can see some of the PML reflectance sensors looking at the light reflected back off the sea surface. These will be monitoring continuously over the next few months as the ferry goes backwards and forwards to France. In the background you can just see a rather wet squall coming over, so I think it's time for us to pack away now and hurry to get to somewhere dry.